So we looked at this PV curve and tried to get our heads wrapped around where it comes from. And if you remember again, we have on the y-axis pressure, on the x-axis we have volume. We have a couple key points that we got to remember on this curve. Out here is my maximum volume. So this is what happens at bottom dead center. At this high volume out here, at the low volume down here, this is my top dead center, TDC, which ends up being my clearance volume. So this is the clearance volume inside the engine. So those are some key points that we got to remember. So this curve, this general shape of this curve, is going to go through, the piston goes back and forth, and we create this kind of a pressure curve in the engine. Now, what happens if we make some modifications? And we've already talked about this. We've looked at engines. So the one example I'll look at over here is that I'm going to lengthen the connecting rod. So I have a longer connecting rod. And you remember the connecting rod is the long rod that goes from the piston down to the crankshaft. So it's this rod in here. So on the left-hand side, you see top dead center, bottom dead center in the original engine configuration. On the right-hand side, you see what happens when I lengthen that connecting rod. So you can see right away, if I do a dotted line across there, that, oh man, that piston went a lot higher up into the chamber. Down in the bottom here, if I do a dotted line across, you can see that it doesn't match, so the piston is higher in the bottom of the chamber as well. And we've already talked about this. We said, oh, hey, man, you know, and if you lengthen that connecting rod, that's going to make the clearance volume a lot smaller. And we can see that here. You know, here's the clearance volume, and I shove that thing up in there. In fact, if you look closely at my drawing, I actually have some interference. So, you know, in reality, this would probably break. But, you know, we're just kind of a theoretical discussion. Let's just assume that it can actually fit up in there somehow. But that clearance volume is a lot smaller. You notice that the maximum volume is a lot smaller as well. Not a lot, but it's a little bit smaller. So, you know, it still has a lot of space up in here, but it's a little bit less than it was before. This is more dramatic up here percentage-wise because this wasn't very much to begin with, and I take a little bit off of that. That's a pretty dramatic percentage change in what's going on. So, So we've done that. We've already talked about that. This is going to decrease the clearance volume. It's probably going to increase my compression ratio and all that. And we kind of guessed beforehand that it was going to give us more power. Let's see why that is the case. So what's changing? So if this was the original, the dark black lines there are my original PV curve for that engine. How does that change with the longer connecting rod? Well, we know right away, hey, with a longer connecting rod, my clearance volume is a lot smaller. So where my clearance volume was here at top dead center, it's going to move to the left. So my clearance volume is going to go to the left. So my new clearance volume is going to be somewhere down here. And I don't know how far it'll move. We could calculate that and figure it out. But let's assume that it moves about that far. Okay. So that volume is going to decrease by that much. Now, here's the interesting thing. The volume at bottom dead center is also going to decrease by that same amount. Okay, so it decreases by a little bit. So the same distance, and if I can be real clever here in drawing, and I'm not that good, but let's assume that we're going to shift this line over the same amount that we've shifted that line. So I'm going to put a new line here, something like this. So this is going to be my new bottom dead center position. So, so what have we done? Right away, we can see we've shifted this curve over to the left. Okay, so what is that going to do for us? Well, let's look at the shape of the curve. Here's the interesting thing. Remember that this curve here is an asymptotic curve. So it actually curves up asymptotically to that vertical axis, to the power axis over here. So I'm going to start over to the left a little bit more like I did before, and we're going to have a pretty similarly shaped curve following this other curve over here. But what's going to happen is that asymptotic part of the curve, as I get closer, so it's going to follow the black, but as I get closer here, it's going to really turn up. So it's starting to turn up as it would go asymptotically again. So we kind of picture this curve kind of curving on around. and going up asymptotically. Oh, man. So what has happened here, man, I brought this up to a lot higher pressure. So that's a pretty significant jump in pressure. So I was here before, now I hit that top dead center at a much higher pressure. So it was a big pressure increase. Well, now what happens when I ignite this fuel, I get my big pressure jump. Boom. And what's going to happen is that pressure jump is actually going to go, because I started higher, it's going to go quite a bit higher than what it was before. So that pressure jump is going to go up something like that. It's going to go up really, really high. Okay? Now, what's it going to look like coming down? It's going to follow a similar shape coming down. So it's going to go up here, something like this, follow a similar shape coming back down till we get down somewhere here to where this was. And then we're going to close that curve with exhaust, and it's going to look something like that. Okay? Now, look at that for a minute. And what do we say about power in an engine? We said that the power is the area in between these curves. Okay? Now, look what I've done to that area. So here's the original area. The black curve is that original area. Look what I've added to it. I've added all of this area over here, and I'll crosshatch that in. I've added all that area to the curve, so made the curve bigger, and all this area up here because of the higher pressures in that chamber. Now I've lost a little bit of area over here, so this was actually a loss from the original, but that's pretty small compared to how much that I've gained over here. So again, what is power? Power is the area inside of the curve. So I went from what was inside the black to what's inside the blue. I've added a whole lot of area. Area is power. What does that mean? More power. That means I'm going to get more power out of this engine just because I have much higher pressures. I'm not adding any more fuel to it at this point or doing anything like that. I'm just getting more power out of it. Wow, so there's a great thing, right? So all we got to do is increase the pressure in our engine and we get more power and we don't have any problems, right? Well, there's always a catch, right? So what is the catch here? So the catch that we run into with increasing pressures in the engine, of course, is the auto ignition pressure. What happens in there? And we've talked about auto ignition pressure before and octane of fuel and all that kind of stuff. As that fuel is compressed, that fuel air mixture, I compress it, eventually I get it to a pressure where it burns on its own. It just ignites and goes. And of course, that's how we capitalize on that concept with compression ignition engines, because that's how we get the fuel to light. We get the pressure high enough, put the fuel in there. But in a spark ignition engine, we don't want that to compress. So as we're compressing that, we don't want it to burn until we hit it with a spark. So what does that mean in terms of this graph over here? Well, let's think about this. We're looking at the pressure. We start with the pressure down here. And in a spark ignition engine, we've got air-fuel mixture in that chamber. And we compress, and we get it up. Look at the pressures going up and going up, going up. Where does the auto ignition pressure have to be for our engine? For that not to burn, for it not to start to burn early, that auto ignition pressure has to be above this corner. So if I extend this over here, my auto ignition pressure has got to be up above this somewhere. So let's say that my auto ignition pressure of my fuel was like right about here, okay? And that's going to be fine, okay? Because I'm going to increase the pressure. It's still not high enough where the fuel is going to ignite, so I'm okay. I light it with a spark, and away we go. That's beautiful. Now, that modification we just made to our engine when we decreased the clearance volume, so we actually took that curve and brought it up around to here. Oh, man, what did we do? What did we do? Look at where that corner is now. That new corner, when we decreased the clearance volume, those pressures went up high. If my auto ignition pressure of the fuel was right here, now my pressure within the chamber is too high, and that gasoline is going to start to burn early, which I don't want. That's engine knock. That's all kind of bad stuff. So there's when we talked about, auto ignition pressure, octane of fuel. Low octane fuel has a pressure down here. High octane fuels are going to have a higher auto ignition pressure. So if I have a situation like this where my pressure in the chamber is above my auto ignition pressure of the fuel, I got to do something with the fuel to have a higher auto ignition pressure so it doesn't burn what I don't want it to. So there's 87, 89, 95 octane, whatever. The higher octanes, I'd have to get a different fuel with a higher auto ignition pressure to operate above that. So that's the other thing that we got to be careful of as we change pressures. But now we're starting to see how those concepts that we've talked about before, here's where they fall on the graph. So we can actually see what they look like on the graph, and visually we can start to see what's happening in there. So that's why these PV curves are important. We look at the area inside the curve and how much power we're getting out of the engine. We look at the pressures and so forth, watch the auto ignition pressure. So those are all key things that are going to help us visualize what's going on in the engine and numerically see what's happening there. So what we'll do now is look at, okay, this is a theoretical performance, nice square corners and all that kind of stuff. In reality, what does it look like? Plus, we're kind of ignored this intake and exhaust stroke up until now. So let's look at all of those concepts in the next video.